Hello classmates and professor, my name is Rebecca Figueredo and today I will be going over an example regarding the square root of 3 being irrational. In order to prove this, I would first like to go over proof by contradictions, as this element is necessary in order to solve or prove our example. So the definition states that some theorems have the form if premise 1 and premise 2 and ... and premise n, then conclusion. A direct way of proving these theorems is to assume that all premises hold true, and establish on the basis that the conclusion is also true. With this in mind, we may now move to our example. Prove that the square root of 3 is irrational. Using the proof by contradictions, we actually assume that the square root of 3 is rational, which by definition means that the square root of 3 can be expressed as the ratio of two integers, n over d, where n and d are simply elements of z integers, and their denominator d is not equal to 0. And if my handwriting is illegible, here it is again. From this point, let's assume, without loss of generality, WLOG, which means without loss of generality, that n over d is reduced, and that their greatest common divisor must be 1, which can be written as greatest common divisor, GCD, of n and d is equal to 1. This parenthesis. And here it is written again for us. Now we manipulate the equation, and that equation was the square root of 3 equals n over d. We manipulate this by squaring both sides, squaring the square root of 3 and squaring n over d. From this we get, and let me use red, 3 equals n to the second over d to the second. In blue, we are going to cross multiply, and we're going to get 3 d to the second is equal to n to the second. And notice I have written this right here. From this point, I want to note that 3 divides n. And by n, I mean n squared. N squared. 3 divides n squared. And this little line right here means divides. Here it is written again. I also want to note that 3 is a prime integer, which means that it is greater than 1 and divisible only by 1 and itself. With this in mind, 3 also divides n. And here it is written out. Now we let n equal 3k, where k is simply an element of integers z. And we take n equals 3k and plug it into our equation, d to the second, 3d to the second is equal to n to the second. When we plug that in, we simply get 3d to the second is equal to 3k in parentheses to the second. After calculating and doing some computations, we get that 3d to the second is equal to 9k to the second, which implies that d to the second is equal to 3k to the second. And here it is written out. We take a second to note again that 3 divides d to the second. And we also know that 3 is prime, since we mentioned it before, which also means that 3 divides d. And here is the explanation. With this, we conclude that 3 divides both n and d. And therefore, it must be the case that our greatest common divisor for n and d is greater than or equal to 3, which is greater than 1. This stands in contradiction that our hypothesis for the greatest common divisor of n and d is equal to 1. So, in this case, we reject the possibility that the square root of 3 is rational. And so, we've come to the conclusion that 3, or the square root of 3, is irrational. And that concludes the proof. If you want a summary of this, here is a summary of the proof with all the details together. Prove that the square root of 3 is irrational, and we've mentioned all of this throughout the video. Notice that again we end up with square root of 3 being irrational, and that concludes my presentation. Thank you so much for watching, and I hope you learned a little bit about this.